Good morning, ladies and gentlemen. On behalf of the Faculty of Computing, I would like to welcome you all to the Technical Session 1, Parallel Session 1 on Computing of the 14th International Research Conference of General Sir John Kothawala Defence University. Due to the prevailing COVID-19 pandemic situation in the country, this conference could not be held physically. Therefore, this session will be conducted online. This technical session is based on the theme of Challenges in Information Systems in the New Normal and will be chaired by Dr. Damith Wickramanayake. Now, I would like to invite Mrs. Harshani Pereira to give you a brief introduction on Damith Wickramanayake of this session.
Thank you very much. Good morning, ladies and gentlemen. On behalf of the Faculty of Computing, I would like to welcome you all to the Technical Session 1, Parallel Session 1 of the 14th International Research Conference of the Faculty of Computing of General Sir John Kothawala Defence University. This technical session will be chaired by Engineer Associate Professor Damith Wickramanayake from the University of Technology, Jamaica. He has obtained his BSc in Engineering from University of Moratuwa, and he is a recipient of a full scholarship from the British Council, where he read for his Master of Science in Computing from the Bradford University, UK. He has done a postgraduate diploma in mathematics teaching jointly from the University of West Indies and Micro Teachers College in Jamaica. He is a holder of a doctorate from Nova Southeastern University, USA. Professor Wickramanayake is an experienced researcher with a demonstrated history of working in the higher education and consulting industry. He is also a reviewer for the scientific and academic publishing, and his research interests include big data, databases, cloud computing, and blockchain. Dr. Wickramanayake also has been playing key roles in IEEE, such as committee member in IEEE MGA Board, Award and Recognition Committee, IEEE MGA Educational Activities Board, Section Education Outreach Committee, and as a member in IEEE Region 3, Southeastern USA. It's with great pleasure that I invite Associate Professor Damith Wickramanayake to chair this technical session. Thank you very much. Over to you, sir.
Thank you very much, Mrs. Harshani Pereira, for your kind words and introduction. We are going to, good morning, everybody who are from Sri Lanka, and good afternoon from people joining from Europe, and good evening, people joining from North America and rest of the American region. Now, my job as the chair to introduce the presenters. Now, before I go to introduce the presenters or the first presenter, let me give you a few rules. The timing of the presentations will be very strict because we have a very restricted time. Each presenter will get 12 minutes. There will be a bell ring at the 10th minute, and then you have to start winding down, and there will be 2 bells ringing at 12th minute, and then you have to stop. And if there is a power failure in your side, we will be switching into your recording that you have sent us already. And then we will proceed after that next to the next presenter. Now I am welcoming everybody. Let me introduce the first presenter, Miss JAWT Chandrasena, undergraduate student from Kothalavala Defence University. She's following BSc Honours in Computer Science. And her topic is Sinhala chat box with recommendation system for Sri Lankan traditional dancers. Ms. Chandrasena, please start your presentation.
Thank you, sir. Good morning, everyone. It's a great pleasure to be here to present our research on the 14th International Research Conference of General Surgery on Kathriarachchi Defence University. Our research is based on Sinhala chatbot with recommendation system for Sri Lankan traditional dancers. We move to the content. This is our presentation outline. First, I will give you a brief introduction about Sri Lankan traditional dancing, the main problems of Sri Lankan dancers we identified during this research, the overall aim and the specific objectives of the research, some related works done by earlier researchers, under the design, the main modules and the features of the proposed system. After that, the methodology we used to conduct this research, the technologies we used to build this proposed system, then the limitations, the future directions of our research study, references, finally acknowledgement. Traditional dance is one of the most popular performing art which act as a main element of Sri Lankan culture. It is started as a spiritual beliefs of people and as a method to expel natural disasters and sicknesses. Though it is highly developed throughout the years, it is one of the domains of Sri Lanka which is not much connected with modern technologies. As a result of this, Sri Lankan dancers still use ordinary methods even to find dance service providers. So initially we conducted a simple survey to find the most common problems of Sri Lankan dancers. There we identified that there is a lack of proper manual or computerized database which contains details about dance service providers. Because of this, Sri Lankan dancers don't have any proper method to find dance service providers in an accessible distance. Here we mainly focused on 4 categories of dance service providers. They are dance choreographers, dance track editors, dance costume providers, and dance props providers. So the main target of this research is to design and implement an e-guide web platform which allows service seekers to find the nearest service providers with the minimum effort. As this is a localized system, we thought of implementing a single chatbot to make it easy to use the system and guide users to fulfill their requirements. These are the specific objectives of our research: computerizing information of Sri Lankan traditional dance service providers, allowing users to find the nearest service provider to their preferred location. Also, this will be useful for service providers to increase their sales and popularity. To build an interactive virtual agent which supports Sinhala language. Over here, we have the related works done by earlier researchers which were useful to us. The paper named Ayurvedic Knowledge Sharing Platform with Sinhala Virtual Assistant has been presented the details about a system which was implemented to provide information about Ayurvedic plants. There they have implemented a Sinhala chatbot to answer user questions. The second research which has been conducted by 4 Sri Lankan researchers have been proposed a system to find the nearest police station to user location. It is based on clarification technology and they have used GPS techniques as well. The researchers of the third paper have been proposed a new user rating prediction method based on machine learning techniques to build more accurate recommendations to user. The fourth paper has been proposed a system with services such as online hotel exploration, reservation, and finding the best path to nearest hotel. These researchers have been used a DigiScar algorithm to implement the function of finding nearest hotel. In the fifth paper, a chatbot has been introduced in social network web pages for smoking cessation. They have used a multi-agent approach to implement that. This is the high-level design diagram of the proposed system. These are the main modules and the features of the system. Let me explain this in detail. Initially, the system identifies the user category with the use of Sinhala Chatbot. Their users are categorized as service seekers and service providers. After that, service providers are directed to the registration page and service seekers are directed to find service provider page. The registration details of service providers are stored in the database and created user profiles for them. If the user is a service seeker, Chatbot asks user location and required service type. Based on the location details, the system generates a list of nearest service providers and sorts them into an order of highest rated to lowest rated. Then the top 5 service providers are recommended for the service seekers. They can select one of them and see their profiles for more information. Also, they are allowed to go for another service provider who is not recommended by the system. So the main problems and limitations we found during this project are as follows. The data gathering process was hard as there doesn't exist even a proper manual database to find data about service providers. So it took very long time to gather all the data, and lack of computer literacy of users. While most people today are familiar with digital devices, there may be some who are not. Also, users may dislike using a computerized information providing platform. As an example, there may be some people who are less confident about information provided by a digital device. So this is the methodology we followed to conduct this research. Initially, we identified the requirement of a proper guidance to Sri Lankan dancers to find the service providers. Then we defined aim and objectives of our research. After that, data gathering process and literature review are done in parallel. Then started designing and implementing the system. After that, system testing and conclusion of the research. These are the technologies we use to build this system: HTML, CSS, JavaScript, and PHP for the website development, MySQL as the database, Dialogflow is used to build the chatbot, and Google APIs are used. Over here, we have the future directions of our research study. The proposed system was basically focused on Sri Lankan traditional dancing. But other than this, there are more inherent dance styles in Sri Lanka. Also, there are Western dance styles are in practice. So this research area can be expanded by integrating those dance styles to this system. And the system can be further developed not only for these 4 service categories, but also for other dance styles as well. Another future development would be to implement the feature to see the costumes of costume providers using virtual reality technologies. So these are the references we used. So we came to the end of this presentation. Finally, I would like to express my heartiest gratitude for my supervisors, Dr. Gunasekara and Ms. Uwanthika, for their constant support and kind guidance. Secondly, for all the lecturers and colleagues who helped us to make this a success. It would never have been possible for us to take this work to completion without their incredible support and encouragement. Yeah, any questions?
Yes, there is. I just want to know, you have in your presentation, I observed introduction and methodology, not the results. Why you didn't show your results?
Yes, as a result, we are providing recommended service providers.
Miss
Shall I
Harshani,
say?
I have to interrupt here. Miss Harshani, she's the president of the session. The question and answers are at the end. Am I right?
Yes, sir.
Yeah.
Damith, sorry, I'm from Marika, but it's not mentioned at the beginning. That's what I asked. Okay, sorry.
All right. That's all right.
Finally, I would like to thank the organizing committee of KDU IRC 2021 for giving us this opportunity to present our work today. So thank you.
Thank you. Thank you. Now we are moving to the second presenter. And I'm reminding again that the question and answers will be at the end of all the presenters. If I did not mention it at the beginning, my humble apology, but we are in a tight schedule because there are 3 more sessions to go for the day. Now, Major RMM Pradeep, Senior Lecturer, Faculty of Computing, General Sir John Kotalawala, Defence University. And the topic he will be presenting is classification of software frameworks utilized in water resource management modeling. Major Pradeep, please come to your presentation. Thank you.
Last Christmas, I had some kind of improbable situation. There, I was in a thought of having a very clear understanding of a particular term. Then I developed a research based on that. Unfortunately, when I was talking that research topic with a set of people, actually they are not in our discipline. They started to talk against me. I wondered. But gradually I understood that we are in an understanding of 2 different meanings of the same term. Folks, the term is framework. I know that now you are thinking, how can I explain, how can I make understand somebody else who is having a different term? Dear ladies and gentlemen, we can do that. By the way, I am Pradeep, and this is a collaborative research with Dr. Edirisuriya. Within next 10 minutes of time, I'm going to answer 4 questions. Number 1, first of all, I try to give the answer to why the meaning of the framework is becoming a problem. In the methodology section, I am going to give the answer to why present understanding is not enough. In resultant discussion, I present you a new classification, but literally, I am going to ask why I say it's a new classification of frameworks. And finally, I move to the conclusion. There, I answer the question why you need to use this or do this. Let's move to the introduction part. So if I open the book of dictionary, the framework, it says that the structure of something built or founded. But if I ask the same question from the water professionals, they are talking something management and scientific component to be integrated to make some decisions. Then I ask, please give me some examples. They show these things like this. You can see the frame software components are there. The management and technical components are also there. Then if I ask the same question from you all, you tell me some lot of technical terms, very fancy words like these things. APIs, DBs, drivers, boards, and Node.js, and lot of fancy words. But the problems come when we are trying to integrate these 2 people. these two people because they have different two ideas. So my research was, I was trying to I was trying to develop a water model software framework. So don't worry about that fancy lot of word, but basically just have understand, I'm going to develop software framework for the water modelers. So then when I tell that research idea, they talk with the idea of their own ideas. So that's why I am saying that the meaning of the framework became a problem. So my aim is to then, I need a classification first of the software framework which can interest on the water modeling. Let's move to the methodology. So I quickly go through the methodology steps. First, I have a seed idea. Then I select a set of literatures. Then I study water software frameworks, and I try to find out the classification schema. Then I start to find out about the water frameworks, and then classify the water frameworks, and finally create a classification map and come to the results. Let's move to the first one, literature review. So in the literature selection, it is very much important in this research because this research is entirely based on the set of literature. So I have paid more attention on this, and basically I start from the Google and then went for the Google Scholars, and I use the connected paper. So it's an interesting tool, online tool. You can find out the history as well as the citation of that particular paper and get to know how that paper is valid for your research. So likewise, I selected 23 papers. In the same time, I found research papers for the software frameworks for the water management, and I used the Scopus and I used the criteria which shown on the screen. Then after that, I had a fair number of papers, 12 papers. So then I studied the software frameworks. Quickly going through the software frameworks which are available at the present, as well as my understanding, I put all these things together. First of all, we start from the design pattern, information hiding, Parnas models, and all these things. We had this kind of situation at the very beginning. Then due to some object-oriented frameworks were developed due to the satisfy this reusable architecture of the requirement. Then the second level, it's become like the second set of framework. And the third set of framework are component framework. So those are talking about, those are providing the independence from the language and the compiler, and talking about the black box and language independence. Then now this is the latest, this is the component framework architecture. And then we move to the aspect-oriented architecture. So it's a different kind of dimension, but it talks about non-functional aspects and the business rules. So then the new addition is like this. And we move to the next one, metadata-based framework. Actually, it's an expansion of the previous one, and it will look like this. And service-oriented architecture, which is the architecture which we are mostly using at these days. This is the latest one, and it provides the cross-platform and the server-based applications and inter-process communication. So the architecture is like this. So you can see all these things are in all together, but there is another one, application framework. So it's not a kind of a framework, but it's the kind of a abstraction of complex business unit and the application domain. So it is like this. Now, ladies and gentlemen, with that, I found 7 software framework. And next, move to the classification. You can classify the existing frameworks using different patterns as shown on the screen, but those are not enough for my work. Therefore, I searched this document and I found that it's called classification of PAT, but again, it's a limited, it's containing limited classes. Therefore, I had to find a better one. So I found 7 schemas of Pranja. So I show the architecture or the referencing method of that document. You can see in the middle, the particular document, and it is the base of most of the document which we are developing today. Therefore, I selected that document. Then I have these 7 schemas to select or classify the existing frameworks. Ladies and gentlemen, now I have 7 schema for framework classification. Then I found then I found different water management framework like this. So these are the 10 papers which I found under my criteria, and the highlighted one are environmental models. So therefore, those were also taken because the water management is there. So now I have 10 frameworks. You can, if I recall, 7 software frameworks, seven schemas, and 10 water frameworks. Then what I did, I have 10, then I try to classify or try to manage using these 7 schemas. Then this is the map which I developed. You can see there is a blank area. That means there's some area in the frameworks which are not covered by the existing things. That's why I am telling that the present understanding is not enough. Then we move to the result and discussion. So actually the analyzing part and the result. So this is the summarized or context version of the map. And you can see that frameworks, there are frameworks and approaches and scopes are there with their strict marks. That means those are approximations only, Therefore, I had to find why those things are very different. And then I took out of these 7 things and I study what they are containing. Basically, these people are talking about, the water managers are talking about on behalf of the software frame, these terms. Therefore, I found that these are the things they are interesting. Therefore, I could be able to develop this new framework or new classification of the framework. So how I developed that? So I had the 7 software frameworks and the new one. So using level 1, level 2, and level 3, and I add the knowledge, the level 4. So from there, I could be able to, that's why I say this is a new classification framework. Let's move to the conclusion. So in the first question, I show you that there is a problem with the understanding of the word framework. Then I show you that there is a gap when we study in about 7, 7, 10. And then I show you the new classification framework. But this is our kit, the new classification. You can see it's in a simple version. We have 4 levels: develop software components, develop software packages, develop software systems, and develop model of the software systems. Then, ladies and gentlemen, level 3 and level 4 having management and scientific aspects, and level up to level 1, 2, 3. That means 3 is the popular with the software engineers. That's you all. But level 4 is the major concern of the water professional. They know very well about that. Therefore, when you develop integrated software, the water professional speaks level 4 framework with you all. Therefore, you should have a better idea about that. That's why I am telling that you want to study this and you want to use this. With that, I come to the conclusion of my presentation. Before I should thank all these people who have done a good work in the history. But there are a number of research papers. Therefore, please read the full version of my research paper, which I share after the presentation. It's in my profile for a limited period of time. With that, I come to the conclusion of my presentation. Thank you all.
Thank you, Major Pradeep. We move into the next presentation. That is Mr. S.I. Baddegamage, visiting lecturer, University of Vocational Technology, next door to the KDU. And his presentation will be on information management of Sri Lankan vegetable farmers, effectiveness of ICT application. Mr. Baddegamage, please start your presentation. Thank you. We are not hearing you, Mr. Baddegamage.
I'm sorry. I already started. I'm Indika Baddegamage from University of Colombo. Whether that I'm working as a visiting lecturer at University of Vocational Training. My supervisors are Dr. Gunasekara and Dr. Lasanthi Silva. Today, I'm going to present some of my research findings about effectiveness of ICT applications about Sri Lankan vegetable farmers. And as you know, that Sri Lanka is an agricultural country with 33% of people are engaging in agriculture-related activities, but their contribution for the GDP is less than 7%. The Sri Lankan agriculture sector consists of several subsectors, and vegetable subsector is one of the major subsector because that is the it is mainly for consumption, and that area is very sensitive for everybody. And the vegetable cultivation, for the vegetable cultivation, farmers require various kind of information through their crop cycle for the crop selection, cultivation, maintenance, harvesting, and post-marketing activities for their farming activities. And this is very much important, and they need their information timely for their to take their right decisions for their cultivation. There are many ICT applications have been developed for Sri Lankan vegetable farmers for many years by targeting for to control price fluctuation, eliminate vegetable wastage, and eliminate poverty among farmers, and by doing all these things by expecting the prosperity of farmers. And the research problem that what we are talking about here, what are the factors which leads to reduce the farmers' continuous use of interactive agricultural information system in Sri Lanka. Interactive information systems become more robust and reliable with the increase of using with interaction. Farmers are, these systems are there for farmers to use, but we have identified that farmers are not using regularly these systems. So the research aims to identify reasons behind rejecting or not to continuous use of these systems by Sri Lankan farmers. And we found that farmers are using various kinds of information sources like formal sources, informal sources, and some traditional information sources. In addition to, most of farmers have access to mobile phones, but they are using mobile phones just to take some information about market prices and things. And we have identified through our, when we are going through our literature, there are several information systems available for farmers like Govia.lk, Govinana, Dialog TradeNet, Agri Price Index of Mobitel, and this PMB's Paddy Marketing Board's website, and Department of Agriculture website. Not only that, there are several apps like Vendapola, Badumila, Goipala are there for farmers to interact. And but with these systems, there are some problems of for farmers to access these informational systems. We can identify them as barriers, and we found them through literature review as well as our preliminary survey, law infrastructure facilities, training issues, and skills and communication problems, and political issues like lack of knowledge about systems, language barriers are also there, and the cost, lack of awareness, and inaccessibility of systems, and difficulties of handling systems, and knowledge lack about the systems and their benefits also can be counted as barriers for farmers to enter into systems in Sri Lanka. And complications in sector level of outside support and farming experiences with the informational availability, farmers' personality, also one of the factors that to access systems and get used into systems and information systems in Sri Lankan by Sri Lankan farmers. But there are several systems available for farmers. Many systems are available for farmers. With these constraints, farmers are still struggling with their traditional methods, unreliable information sources, and problems available in the agriculture community is still there. Therefore, that we follow normal procedure to study the problem, and first we started with literature survey to identify the nature of the problems available in the agriculture sector, and given solutions also identify through our literature survey. And we found several information systems and apps are available, as I listed earlier. Apart from that, we went through one of these apps and find out, investigate about the interaction of farmers with apps, and we study about one app and selected 3 vegetables, and we recorded 52 weeks data of farmers in 2019. In addition to that research object, weekly market prices from the Dambul Economical Center by going through Hearty weekly price index of the same products. Then not only that, we did some kind of field survey as well to get farmers involvement and farmers ideas and farmers ability of using ICT equipments. And we gave a questionnaire for 105 farmers, and we got 76 response from farmers. Not only that, we had some kind of informal kind of unstructured interviews with 16 farmers in Sonottara village in Matale district to get some information about their ICT ability of using ICT ability. So these are the price information of 3 vegetables according to Hearty price index for 52 weeks in 2009. So you can see that prices are fluctuating rapidly through over the year. There are very high prices as well as very low prices. And not only that, we have investigate the user interaction, farmers interaction with given app for 53 weeks, and they have received only 120 selling offers through over the entire year. So we can see these are the data for these 3 vegetables through over the year, and farmers selling offers got for these 3 vegetables through over the year by farmers. And here we can see the ability of farmers ICT usage. So they are very low in using ICT. They are not using internet, and they are not using IS systems, and they are, even though that they do have mobile phones, they don't go for systems. They are just going here and there and paying with it, and maximum usage that they are getting, maximum support that they are getting from the mobile phone is to check the market price from the morning or in the evening or the day before they are getting the harvest. So these are the apps that we investigated, and finally we can see the market prices are fluctuating rapidly. According to these information systems, there are objectives of these information systems to establish market prices and control price fluctuations and eliminate vegetable wastage. But still these problems are there. That means even though that we have systems, since farmers are not using these systems, these problems are still available in the field due to some problem. Actually, what we wanted to identify why these farmers are not using these systems and what are the problems behind this, whether they are lack of knowledge, lack of ICT ability, lack of problems of handling these things, or language barriers and so on. So this is what we have identified and we have discussed during this particular research. And finally, we wanted to identify why these problems are still there in the field and how can we come across with better system to provide for solutions for farmers to eliminate price fluctuations, vegetable wastage, and give a better price for farmers to eliminate their poverty. So these are my references, and we went through several papers during our research activities, and I'm thanking for Nilis of University of Colombo and my supervisors for their support given, and as well as KDU for organizing this wonderful event for us to present our research findings. Thank you very much.
Thank you, Mr. Baddegamage. We are moving to the next presentation now. The presenter will be Miss JAN Erangika. She did her bachelor's degree in Information Systems, Faculty of Applied Science, Sabaragamu University of Sri Lanka. The presentation will be on effort estimation in agile software development and empirical study in the Sri Lankan context. Ms. Erangika, please come to the podium.
Thank you, sir. Good morning, everyone. I'm Wijesingha from Sabaragamu University of Sri Lanka. I'm going to present my research study entitled on effort estimation in agile software development within Sri Lankan context. There are three authors, me, JN Erangika, my supervisors, GAC Herath, and Professor RMKT Rathnayake. This is the content of the presentation I'm going to present now. First one, introduction, then methodology, results, discussion, conclusion, differences, and finally, acknowledgement. Agile software development methodology is the most popular software development methodology in the 21st century. Gaining customer satisfaction by delivering timely and quality software is one of the main principles of Agile. At that point, effort estimation is a key function for timely quality product delivery. So, several researchers have done on Agile effort estimation in the software industry worldwide, but hard to find within Sri Lankan context. The state of the practice of Agile effort estimation within Sri Lankan Agile teams and the factors which affect to the effort estimation accuracy is investigated deeply by this research. These are the research questions which covered the whole research study. First one is, what are the most commonly used Agile effort estimation technique by Sri Lankan software development teams? Second research question is, how accurate is the effort estimation done using above techniques? Third one is, which effort predictors are used within the aforesaid techniques for effort estimation. Effort predictors mean cost drivers and size metrics. Fourth one is, what are the factors that have an impact on the accuracy of the effort estimation? When considering the methodology I have followed to do the research study, first of all, I have done the exploratory investigation to identify the lack of the given empirical research area within Sri Lanka, and then conducted the survey with the aid of an online questionnaire. That online questionnaire was distributed among the software professionals using LinkedIn social platform, and the collected data was analyzed according to quantitative method using SPSS tool. Descriptive analysis, measurement model analysis, behavior analysis, correlation, and regression analysis were conducted to retrieve the final result of the research study. When designing the questionnaire, it was designed by considering the effort estimation technique used and factors affect to the effort estimation accuracy according to this research method. This research method model was designed using the factors I have collected at the systematic literature review I have done at the phase of the study. Then the 114 responses were collected using the online questionnaire, and at the first descriptive analysis were conducted. From that analysis, I have identified according to the first table this pane. Scrum is the mostly popular software agile methodology within Sri Lankan agile teams, followed by Scrum Burn, Kanban, XP, Lean, and so on. Then I have identified that expert judgment, planning focus, use case point, COCOMO, Delphi, disaggregation are the most used effort estimation technique among Sri Lankan agile teams, and also expert judgment, planning focus, use case points are the mostly used ones. Then identified that the most popular, mostly used size metric is the story point among Sri Lankan agile teams, followed by use case points, function points, and line of code. Then the measurement model analysis were conducted. Measurement model analysis were conducted to ensure the validity of the use measures in the selected variables. This analysis was performed based on the validity and the internal consistency. When considered the validity test, it was performed using Casimir Orkin measure and Bartlett test of spacity. The value of KMO measures the adequacy of sampling, while BTS statistically tests the soundness of correlation within correlation matrix. When in this table, EJ for expert judgment, PP for planning focus, UC for use case point. According to the table, analysis produce more than 0.7 KMO value for each effort estimation technique. And BTS ensure the good soundness of correlation since all significance values less than 0.05. Both tests strongly indicate that the analyzed sample size is adequate. When considering the reliability test, it was done using the Cronbach alpha. Cronbach alpha was used to measure the internal consistency of the questionnaire. Result of the Cronbach alpha for all coefficient is greater than 0.5. So level of the reliability could be considered as high. Then the behavioral analysis were conducted. Behavioral analysis were conducted to all the pilot question in the questionnaire. Among them, two result of the two questions displayed here. According to the first graph, most of the responses agree with that the accuracy of the effort estimation strongly depend on the technique used for the effort estimation process. According to the second table, when comparing to the according to the second table, all responses agree with the statement when comparing the actual effort required with the estimated effort. The accuracy of the estimated effort using the expert judgment, planning program, use case point technique was high. Then the correlation analysis were conducted. Correlation analysis were conducted to identify the relationship between effort estimation accuracy and the factors like cost drivers for each effort estimation techniques. In this table, at the correlation analysis, I have considered effort estimation accuracy as the dependent variable and communication factors, team expertise factors, social factors as the independent variables. According to the result of the table, it's clear to represent that there's a positive correlation with the dependent variable effort estimation accuracy and the independent variables. Then the regression analysis were conducted. Using the regression analysis, I have identified many models related to each effort estimation technique: 2 for expert judgment, 3 for planning focus, 2 for use case point. Among them, according to the Oscar value, I have summarized in this table most suitable models. Then, according to the regression analysis, and the in this table identified the what are the mostly affected factors to the effort estimation accuracy while using the each effort estimation techniques. According to this table, while effort estimation done using the expert judgment and use case point, team expertise factors and communication factors affect the effort estimation accuracy. When using the planning focus as an effort estimation, communication factors, team expertise factors, and social factors affect the effort estimation accuracy. At the final, the regression method was used to perform the structural model analysis. This was used to assess the impact of the variables which have been taken as independent and dependent variables. The defined model at the earlier in the research methodology was redefined again as the most suitable model according to the analysis result to the Sri Lankan data. As this displayed in the redefined model, you can see what are the factors affect the effort estimation accuracy when do the effort estimation using each effort estimation techniques. At the finally, investigation emphasizes that communication factors, team expertise factors, social factors, and some project related factors affect the accuracy of the effort estimation process within Agile software development. That effort estimation accuracy using planning focus technique depend on communication factors, team expertise factors, and social factors, while effort estimation accuracy using expert judgment and use case point technique depend on only communication factors and team expertise factors. What are these communication factors, team expertise, and social factors? So these are the factors coming under those communication factors, social factors, team factors, and project related factors. Here, this communication between team members, client involvement in the effort estimation, community in the team, prior experience in Agile software development, prior experience within the selected effort estimation technique, prior experience with the type of software system developed, the small size task, and effort estimation done by same team who developed the system increase the effort estimation accuracy, while linguistic diversity between team members, cultural differences, distributed project teams, lack of domain knowledge, lack of knowledge of required technologies, unclear, unstable, and misperformance requirement decrease the effort estimation accuracy. And also, we have identified that there is some effect to the effort estimation accuracy from the project scope and the type of software as well. When conclude the research study, it's identified that Scrum is the best Agile software development method to use within Sri Lankan Agile teams, and also use effort estimation technique, cost drivers such as communication factor, team expertise factors, and social factors, project related factors such as project scope effect to the effort estimation accuracy. And expert judgment is the best and most popular effort estimation technique to use in Sri Lankan software companies, followed by planning program use case. And also, story points are the mostly used size metric. These are the references I have followed at this research study, and my supervisors are immensely helpful and guided me to get success this research study. So my forever gratitude for them, and also to the KDU, or the organizing committee, to organization this and she gave us the opportunity, and also thank you everyone for helping me at this research study. So this is my this is the end of my presentation, and thank you.
Thank you very much, Miss. Thank you very much for your presentation, Ms. Erangika. We are moving to the next presentation by Miss P.R.D. Wijesingha, lecturer, Faculty of Computing, General Sir John Kothalaval Defence University. She will be presenting on the role of workplace cyber incivility and personality traits on employee knowledge sharing behavior. Ms. Wijesingha, your presentation. Thank you.
Thank you, sir. Very good morning, all. Our study is based on the role of workplace cyber incivility and personality traits which plays on knowledge sharing behavior. Outline of the presentation includes introduction, literature review, research methodology, research findings, and discussion. The modern organizations are fueled with new set of knowledge and employees mutually share knowledge. However, knowledge sharing is not always guaranteed as it does not occur automatically at the workplaces. Therefore, we purport that workplace cyber incivility could be a reason for hinder knowledge sharing. When we considering facts and figures around workplace incivility, 50% of staff experience or witness workplace cyber incivility. Therefore, there is a dearth of research focusing on barriers for knowledge sharing behavior. There are many empirical and knowledge gaps that exist in the literature. Electronic aggressions such as certain comments, gossips, irritable emails, and short or no response for email led to hinder knowledge sharing behavior. And also, victims of such practices are less likely to share knowledge among others. Knowledge sharing behavior is a unique value that determined by an individual's personality traits. Workplace cyber incivility has given less attention due to inherent difficulties in identifying such behaviors. Based on these theoretical gaps identified, problem statement of the study is organizations achieve a competitive edge by developing and using knowledge and information, which in return develop products, services, ideas, and information. Therefore, organizations onboard employees, those who are rich in knowledge sharing behavior. However, employees do not share knowledge as expected, which is puzzling. Based on the background and the problem, there are two research questions to address the knowledge sharing behavior among employees. First, does workplace cyber incivility have an impact on knowledge sharing behavior? Second, do personality traits mediate the relationship between cyber incivility and knowledge sharing behavior? Based on these research questions, relevant research objectives were derived. When it's come to literature review, knowledge sharing behavior can be defined as the degree of one's positive feelings about sharing one's knowledge. There are two types of knowledge. Explicit and tacit knowledge are decisive for companies to expedite their competitive advantage and profitability. Cyber incivility can be defined as computer-mediated, less detrimental behavior that violates mutual respect and norms that hinder knowledge sharing behavior. So abusive supervision and less detrimental behaviors can reduce knowledge sharing behavior. Personality traits can be defined as the individual characteristics and behaviors organized in a way that reflects the unique adjustment the person makes to his or her environment. So knowledge sharing is based on individual unique set of personality traits. However, no study has yet explored the relationship between workplace cyber incivility, personality traits, and barriers for knowledge sharing behavior. The theoretical framework has been developed based on the theory of trait activation. There are three main hypotheses.
First one is to identify the association between cyber incivility and the knowledge sharing behavior. Second one is to identify the association between cyber incivility and personality traits. Third one is to identify the association between personality traits and knowledge sharing behavior. Final one is to identify the missing link among cyber incivility, personality traits, and knowledge sharing behavior. When it's come to research methodology, this study predominantly designed in the positivistic research paradigm, quantitative research approach by adopting survey research design in a cross-sectional time frame. Unit of the analysis is individual, IT sector, software development, employees. And when it's come to sample size, 350 employees were selected from the population and convenient sampling method were used to collect the data through online self-administered questionnaire. And data were collected, reliable and validity measurements were used to measure the construct, and data were analyzed through SPSS 25 and AMOS 23 for structural equation modeling. When it's come to analysis and research finding, descriptive statistic of the study demonstrated 2.90 of workplace cyber incivility and percentage rates with more than 3.3. And yes, when it's come to extraversion only, we have identified 2.63 of extraversion and 2.65 of knowledge sharing behavior. Output data for correlation analysis indicates the negative relationship between workplace cyber incivility and the knowledge sharing behavior. There's a weaker relationship between cyber incivility and personality traits. There's a positive relationship between personality traits and the knowledge sharing behavior. Weaker relationships paves us to identify the mediating effect of personality traits. So therefore, we have tested the parametric assumptions to ensure the appropriateness of a statistical tool. Therefore, it ensures that data were normally distributed and linear, and there was no significant multi-collinearity issue, and Herman single factor tests were performed to identify the common method bias, and it ensures that there's no any single factor issue because the highest value is 26%. Structural equation model is twofold: measurement model and the structural model. According to measurement model data, average variance extraction ensures the conversion validity of the model, and composite reliability more than 0.7 ensures the reliability of the study, and there were discriminant validity issue throughout the research. However, we have identified the optimum level of discriminant validity. When it's come to model fit indices, C-mean and degree, divided by degree of freedom value is 3.899, which is less than the threshold value. Therefore, this study is considerable in an acceptable model fit for the confirmatory factor analysis model. The Ramsey value of less than 0.108 reflects a goodness of the fit. Ramsey value ensures the adequate fit of the measurement model of the data. CFI, NFI, GFI, and TLI important to measure the measurement model fit of incremental indices. CFI and the TLI is almost close to 0.9, which is the threshold value, although GFI and NFI values are below the threshold value. Other indices reflects the goodness of the model. So therefore, we have run the structural model. According to structural model, output data emphasize the negative relationship between cyber incivility and the knowledge sharing behavior, and it is significant under the 95 confident level. And the R square, it explains the 26% of the total variations of knowledge sharing behavior. Moreover, personality traits partially mediates the relationship between cyber incivility and the knowledge sharing behavior. However, agreeableness was not statistically significant because it shows the 0.51% of p-value. So according to bootstrapping output, it ensures the partial mediation between set variables. Based on the findings of the study, it is concluded that knowledge sharing behavior is critical for organizational survival and competitive advantage. So perceived organizational cyber incivility practices can negatively have an impact on not only for employees, but also for teams and organizations. So there's a relationship between cyber incivility and personality traits. And there's no relationship between cyber incivility and agreeableness. personality traits of extraversion, conscientiousness, neuroticism, and openness to experience partially mediates the relationship between cyber incivility and knowledge sharing behavior. However, agreeableness does not mediate the relationship between said variables. This study contributes to the organization of behavior literature by connecting cyber incivility, personality traits, and knowledge sharing behavior. Theoretical implications of the study includes deployment of the right predictor for knowledge sharing behavior. In this case, it's cyber incivility, which is a less detrimental behavior in organization, employ the rarely studied area of cyber detrimental behavior and contextual contribution for IT sector in Sri Lanka. So managerial implications or practical implications of the study includes identify the workplace cyber incivility behavior, to develop proper policies, procedures, and training, a piece of training and development program to educate employees in the organization, and continuously update procedures and policies for knowledge sharing behavior as well as cyber incivility on the organization, and onboard people with those who are rich with personality traits and ethics, and then finally employee engagement and knowledge management system is of importance for employees, organizations, and society. There are a few limitations of the study. First, we have used measurement scale to measure the construct where there is possibility for common method bias. However, according to Potsakov, we have used statistical remedies and data collection period was a limitation because we have collected data in a pandemic situation that led to the convenient sampling method, and discriminant validity issue was there throughout this research. However, we have identified the optimum level of discriminant validity. To conclude the presentation, we focus on the suggestions for future researchers. Whoever who interested in the employee knowledge sharing behavior, it is suggested to extend the scope to all IT sector organization in Sri Lanka. We have limited to software development organization and exploratory studies with moderating different moderating effect. We have used mediating effect and longitudinal studies for knowledge sharing behavior, and exploratory studies for barriers for knowledge sharing behavior, and finally identify the most significant personality traits among these 5 personality traits. I will conclude the presentation by saying workplace cyber incivility is a prevalent form of an organizational less detrimental behavior that hinder knowledge sharing behavior. Despite its subtle and ambiguous nature, it can be deeply and broadly detrimental, so that organizations should consider knowledge sharing behavior of employees and cyber incivility. Thank you so much.
Thank you very much, Ms. Wijesingha. That is our last presentation, and we are moving to our question and answer session. We have 15 minutes of question and answer. Please direct your question to the relevant presenter. We can start now. Please go ahead.
Okay, good morning. Can you hear me?
Yeah, we hear you very clear.
Yeah, first of all, thank you so much for all the presenters for their comprehensive presentations. My question goes to Mr. Baddegamage. Mr. Baddegamage, can you hear me?
Yeah, sure.
My question is, you have done a very interesting, timely, important research. And my question is, as per your experience with this research, what is the most crucial reason which limits the implementation of ICT applications to the farmer community?
Actually, most important thing is the language barrier, my understanding, because they are using mobile phones, because we have personal experiences with farmers and they are using mobile phones. So, the main problem that we do have all these information systems and apps are running on English base. So when it comes to English, so from there itself, it has become a constraint for farmers to get into the system. So that is the mostly, effective factor according to my understanding and according to our research studies.
Right, thank you.
Good morning. I want to give.
Yeah, you are using two equipments. Can you switch off one of your equipments, please?
Yeah, sure.
Can you hear me? Good morning. I want to proceed my question to Miss D.R.D. Wijesingha. What are the suggestions that you can give to minimize the cyber incivility according to findings, ma'am?
Yes, Lakshanta, that's a great question. Actually, cyber incivility itself, it's difficult to identify because when it's come to email, and sometimes there are people, those who sending lengthy emails. However, we sometimes send just small emails. So therefore, it's difficult to identify these detrimental behaviors. So what we can do is, so we have identified personality traits play a big role when it's come to identify cyber incivility in organization. First, organization, what they need to do is they need to identify the personality level of their employees, and then what we can do is we need to groom them to develop their personality traits. So first thing is proper training and development will help to identify the cyber incivility, and then we can focus on cyber incivility. And second, we need to have proper policy framework to identify these kind of detriment cyber incivility, because organizations for address this kind of less severe things, they don't have sometimes policies. To address cyber harassment and cyberbullying, yes, they do have. So therefore, it's better to have proper policy framework to identify these things. And at the same time, all the time, we need to have a proper engaged workforce when it's come to organizations. So through these engagement mechanisms, actually, we can mitigate this kind of cyber incivility practices in organizations.
Thank you, ma'am.
Good morning. I'm Nirosha from KDU again. So this question is again go to Ms. Wijesingha. So it's very interesting the area you have used. I have just a question like, so you have already selected on one particular segment in order to identify these problems. So why you, I mean like, so easy, why you have select, is there any reason to select only software companies and randomly selected convenience sample? You have used a convenience sample, and is it a specific reason to use this method, or like have you gone through with the current cybersecurity policies and those things which is related in our Sri Lankan context?
Thank you, madam, for the question. Actually, we had to limit to this software development. Why? Because we have collected data in a pandemic situation. So we just wanted to expand our population to IT sector, all the organizations in Sri Lanka. However, with the time limitation and because everyone was working in a work from home environment, so that's why we just based on the SLASCOM report, we had to limit to software development organization because with the availability, we have conducted interviews before distribute this questionnaire among these people. So we have discussed with IT people, and then only we have identified that they have this kind of cyber incivility issue there. So that's why we have limited to this organization. So that's why in limitations also we have mentioned that we have a limitation because we just limited to this particular organizations only. And
Yeah. Yeah, so what my thought is like when you're also talking about the policy development, right? Your concern is there to address the policy development in the Sri Lankan context. So do you think that cyber incivility is only for this particular sector, or there are with the pandemic situation, we have already moved work from home situation and many people are using. So therefore, what my suggestion is like you can select different segments, and when you are going for a policy development, you have to consider all the people who are facing this cyber incivility issue. So with that content, you can come up with a broader understanding, and then you can go with the policy implementations. So that is my suggestions for this one.
Thank you
So much. Yes.
Thank you, ma'am.
Good morning, sir. I'm Officer Cadet D. Sataraga. My question is goes to Major Pradeep, sir. So my question is, when we convert water managers' requirement to the software system, so there's a knowledge gap between water managers about the software development. So in this research, how you give a solution for this?
Taraka, could you please ask that question again?
Yes, sir. So when we convert water managers' requirement to this to a software system, so there's a knowledge gap between these water managers and the software developers. So there's requirement how it
right, filling in the gaps, that gap, no?
Yes, yes,
right. Okay, thank you asking for that nice question. So I will share one of the slide with me. Right, I think you can see my slide. So actually, there's a big gap. So today I was talking about the software frameworks, and the framework word itself having a problems regarding between different disciplines. So in this context, so you can see the pink side. The pink one are the proposed classification. So from first, second, and third, we know very well, right? So that means software languages and software platforms and technical and business platforms, how to gather the requirement and how to evaluate the business requirement and so on. So everybody know, that means software side we know. But you can see the scenario 1 and scenario 2 left side. There are two scenarios. So those are the things where the water managers are looking for. So in the level 1, you can see optimize the urban watershed culvert. They are having non-functional requirement of direct requirements. So we can ask from them those things, and we can quickly automate this kind of requirement. So that thing is happening basically when we are automating thing. But the scenario 2, you can see that is the gap from where? From the water managers to software engineers. In the scenario 2, you can see the concept components are stakeholders, and the specific of the conceptual component is somewhat go beyond the software engineers concepts, as well as it's go beyond the water management concept also. Therefore, this is the gap where we cannot, that means water managers and the software engineers cannot understand. For an example, water engineers say, I want to do like this. then the software engineers can say, yes, we can do like this. But the gap is start from framework level or the conceptual level. You can see the stakeholders specification of the conceptual component of the scenario. So their disciplines, non-functional requirement of each stakeholder, as well as manage the conflict requirement among the disciplines. Those kind of things are not handling by a particular thing. In there, what you have to do, sit together with the water managers and the software engineers, because water managers in the scenario 1, software engineers are in the level 1 and 2 and 3. Then amalgamating these two people, they can develop level 4 conceptual framework. Then only they can automate the component. Then only the gap in between these two can be filled, because there are no purpose to fill this gap. It's a collaborative work of these two people. So that's how my suggestion. Thank you.
Okay, good morning. This question goes to Chandrasena. I think the number 193.
Yes, ma'am.
Yes. I just want to ask you how you are going to verify the accuracy of your chatbot and how you are going to evaluate the performance of the system.
Madam, so we hope to use this system by giving to users. I told that initially we selected some group of dancers to conduct this research with our initial survey. So I hope to give them to do the testing of my system. So there I hope to get their reviews for this chatbot accuracy and all the other things in my system.
That means still you did not verify your system with the existing one.
No, madam, as this is my final year project, we are still working on the testing phase of the system.
Okay.
Good morning. I am Buddhika. My question goes to Ms. Erangika. What is your sample size and how do you measure? How do you justify it?
Sorry, ma'am. Can you ask the question again?
What is your sample size and how do you justify it?
My sample size was mainly I have collected 114 responses. So my sample size is that and collected using the software industry professionals using the online questionnaire within LinkedIn, using the LinkedIn social platform.
Thank you.
Excuse me, actually, I also have one question from Ms. Erangika. Actually, in your research, did you focus on the requirement changes when you're aligned with the context? Because in software companies in Sri Lanka, the effort estimations are really varying because of the in between changes of the product owners or the clients. Did you focus that thing? I'm just need a clarification on that.
No, I just focused on only the matter what are the effort estimation technique which gives most accurate effort estimation to the team within the changes requirement. I mean, Agile, when I consider the Agile, it's always changing, requirements are always changing. So I mostly attended to the how the accuracy change according to the using effort estimation techniques.
Okay, thank you, Miss Erangika.
Yeah, Thank you very much for questions and answer session. That ends up our question and answer session. Now our next one, my summing up part. We had 5 excellent presentations. Why I say it is excellent? They are very timely and they are very relevant and they are very appropriate. We had chat box in Sinhala for dancers. Canadian dancing is very popular and very unique. And then we had a presentation, water resource management. WAVA, or in English we call tank, very unique to the world. Nowhere on the earth there are WAV or tank. Sri Lankan, 2,500 years old WAV system we have. Say, Mr. Major Pradeep was talking about water resource management. And then the third presentation we had was vegetable farmers, Sri Lankan vegetable farmers. That was a statistical analysis, data gathered in Magammana area and other areas. And in lockdown time, management of vegetables is very important. Everybody know that. And then we had another presentation, Agile software development in Sri Lanka. Sri Lanka is very popular for software development like India. And Agile development is a new system compared to the waterfall method. That's the old method. Say that is very timely. And the last presentation was cyber incivility. The incivility versus knowledge sharing. I just realized that there is a negative correlation between those two. Very good 5 presentations. Let me go to my second part of the summing up. Thank Vice Chancellor of the University General Sir John Kotalawala University, Major General Milinda Piris, Deputy Vice Chancellor Academic General Sir John Kotalawala University, Professor K.A.S. Dhammika, Dean, Faculty of Computing, Dr. Asela Gunasekara, President of the Technical Session 1, Parallel Session 1, Mrs. Harshani Pereira, excellent job helping me, communicating with me, and you know, in Jamaica, this is almost close to midnight now, and they did a great help. And the next is rapporteur of this session is Miss R.G.C. Upeksha, one of our own KDU graduate. Now she is an instructor. Now, according to our session, refreshments, I think that is a mistake because refreshments should be virtual. I am assuming there is no refreshments, and maybe you might have to have refreshments at home. I don't know, there are virtual refreshments, but anyway, that ends up our session. Thank you very much, especially for the presenters. In this lockdown time, they came and did excellent presentations. And thank you again for other invisible people who really helped to make this session practicable and active. Thank you very much, everybody. And from Jamaica, it is good night. And In Sri Lanka, it is good day.
Thank you, sir.
Thank you.
Now we have come to the end of the technical session 1, parallel session 1. On behalf of the organizing committee, I would like to extend our gratitude to Dr. Damith Wickramanayake for chairing the computing technical session 1, parallel session 1, and to all the presenters. Also, we highly appreciate the participants who have joined online to this session. Due to the prevailing COVID-19 pandemic situation in the country, this conference is conducted online. Therefore, on behalf of the Vice Chancellor, a token of appreciation to the session chair and certificates to the presenters will be delivered in due course.